So thank you for joining us today. Here we are with the Atexto team and the Yobe team. And the idea of this webinar is to give you some insights into working with clean data, and how this clean data can be processed correctly with an ASR and STT engine. We will show you how Yobe can extract dialogue from environments, very noisy recordings. You'll be surprised to see how Yobe application works and how we can extract the dialogue and the difference between clean dialogue in files and non-clean dialogue, and how that the accuracy is affected by the ASR engines. So here with me today, we have the Yobe team and the Atexto team. Let me introduce you to Ken, CEO of Yobe, and he'll tell you a little bit more about his application.
Sure, thanks Alejandro. So at a high level, Yobe is an adaptive software platform that extracts unique metadata in a way that preserves the voice's unique linguistic and biological markers. Specifically, we focus on low SNR environments. So in essence, we deliver what we call intelligent listening on the edge. We are a device agnostic, software-centric solution that can work with particularly any form factor of devices that needs to capture clean voice for whatever analytics you want to do on the back end. So what we're going to do, I'm going to have our audio engineer, John, who's also in the office today. He's going to basically do a quick demonstration to show how we can extract those biomarkers from very noisy environments. And then, of course, we'll pass that information to the Atexto team so you can run that through various ASR engines. So I'll pass it off to John.
Cool. Thanks for having me, guys. I'm going to run a quick demo. What we have here is a simulated environment where our application is running on a standard Motorola smartphone. You should see the screen to the next to me, the side. I have a speaker here in which will be playing the noise environment off of it. The noise environment that I've chosen today is a typical car scene environment. So it has engine noise, just noise from the road, kids yelling in the back of the car, a radio playing. I've placed the phone relatively close, within a few inches of the speaker, to kind of create a very low SNR, so about -15 dB to -20 dB SNR. I'll be standing, I want to say, 3 to 4 feet away. So I will go ahead and start the app, run the audio scene. I'll make a quick recording of common commands that you may be saying in your car. And then afterwards, we'll listen to the before and after. So here we go. Show me directions to the nearest playground. Tell me when my CVS prescription is ready to be picked up. Roll down the back windows. What will the weather be like in 3 hours? Text my dad and remind him to pick up the kids from school. So there we have it. That was the recording. The mic is placed in proximity, so you were hearing about what the phone was hearing, but I'll play that back for you so we can hear the original signal as the phone heard it. The signal after it's been processed by Yobe. Show me directions to the nearest playground. Tell me when my CVS prescription is ready to be picked up. Roll down the back windows. What will the weather be like in 3 hours? Text my dad and remind him to pick up the kids from school. So as you can see and probably hear, Yobe was able to extract the voice metadata, significantly reducing the level of the noise there. And as you can see in that signal, you can see the peaks of the voice audio. So obviously this matters how we hear and see it as humans, but what really matters is can a machine pick up on this and extract that metadata as well. So now we'll pass it back over to Atexto and they can run their ASR demonstration for us.
Excellent. Thanks, John. So you can see the impact of the Yobe app and how we can extract the clean audio data from the voice of the person in the automotive creating the commands for the voice assistant. This is a typical use case, and it shows how important Yobe is in noise reduction and extracting that data needs to go to through the ASR. Imagine without an application like Yobe doing this type of noise reduction of very noisy environments, then you would almost not be able to process the speech to text on an ASR. And don't take my word for it. I'll show you on our application. Let's see. So Atexto has built an ASR comparison module, which we currently provide to the voice industry to benchmark this type of data sets, right? And we have created 2 projects. One that included several audio files in a very noisy environment that was provided by Yobe, and another one where we processed the same files after they were processed by Yobe. So let's look at the difference between the results. In the first example, we have in both projects, we have plugged in several ASRs through the open APIs. You can see 6 ASRs plugged in here that we chose randomly for this project. And you can see that the Yobe files that have not been processed by Yobe and are very noisy, the ASRs are pretty much not able to produce any words from those audio sets. So they're giving pretty much 100% word error rate for those files. If we jump into looking at the files that have been processed by Yobe and extracted the correct audio, then you can see that the impact on the word error rates for the ASRs is very significant. We have gone from 100% word error rate to 6% error rate on the Amazon Transcribe ASR, from 100 to 10% on DeepGram, from 100 to 49 on Google, and so on. I mean, every ASR on the original files was around 100% word error rate, meaning it's not picking up any of the words from the voice commands. And after it's been Yobeized, you can see that there's significant improvement. We can even look at this per file. So this is the web benchmark report that can be extracted directly from the application. And you can see that even for some files, there's 0% word error rate after it's been processed by Yobe and the audio has been extracted from the person creating the commands on the voice assistant. If we look at the previous files, which did not include the Yobe processing, you can see that almost every file is getting 100% word error rate. So to close on this, Yobe is a very powerful platform that will extract voice from very noisy environments, and Ken will do some closing statements on this. But you can also see the Atexto application and what we have built to process this kind of comparison. So even if we were to look at individual files, right, we have built this platform that lets you plug in any open API for ASRs with workarounds to process different ASRs. and you can look at all the word error rates per audio file. This is an example of a Yobe-sized file, which has a significant reduction on the word error rate. So you can look at all this information very granularly inside the Atexto platform. But again, the main focus is you need to work with clean data. It's a good thing to work with Yobe and extract audio data before it is processed by a speech-to-text engine, because there's a huge difference, basically 100% error rate to a reduction that is around 10% error rate, which is a normal ASR word error rate. So with that, I'll pass it on to Ken if he wants to do some closing statements.
Sure, thanks. And I just wanted to just follow up on the demonstration, and thanks for inviting us to do this. Our focus has always been to try to retain all of the robustness of a voice through the signal processing efforts, specifically in those high noise environments. Now, negative 20 dB SNR is not a usual use case for most of us when we think about using voice commands or any type of speech to text applications. So it's a little more aggressive than what you would find in an everyday environment. However, because we are agnostic to who the ASR partner is, and we don't create artifacts that adversely affect different ASR and backend platforms, it makes us a very simple plug and play type of solution because we are software centric and we can be device agnostic. And so now to say if you had a partner that wanted to work to tune to our solution, I mean, those exponential benefits would be even further. But right now, just as a simple plugin, if you want to call it that, or a downloadable solution, we are able to work well with any ASR partner or biometric partner. We retain the biomarkers that we have a few customers that are in the voice biometric market as well that need clean data in noisy environments. And so, we'll put our data up and feel free to give us, contact us with more questions or information, and we would love to engage in a chat.
Excellent. Thanks, Ken. And thank you, John, for the wonderful demo that kind of shows very clearly how Yobe affects the audio files positively in this type of noisy environments. About Atexto, please remember we are a company that will support speech recognition projects all the way from creating voice data, transcription data, and metadata with annotation and so on. But today, the main focus was on showing you the ASR comparison module, which is completely agnostic to any ASR. We can plug in any ASR and get the word error rate percentages, and even more. We're now doing token error rate for capitalization, for punctuation. We're measuring bias on the different audio files, whether they're constructed by having different people from different genders or different age categories. We are able to combine bias measurements against word error rate, token error rate, etc. So in essence, Atexto is there to collect, to benchmark, to manage speech data, transcription data, and labeling data to grow your models of speech recognition. And we can help you choose also what type of ASR you should be embedding in your applications, what type of ASR you should be hiring for your contact center, for example, or for your automotive environment, and other use cases. In essence, this application is there to support anyone that needs to choose speech recognition technology. And with Yobe on top, the speech recognition technology is much more effective. So with that, it has been a very fast presentation, and we thought we were going to take a little bit more, but I think we have showed you everything. So please remember to contact Yobe directly or Atexto directly to get more information on this. Look at our applications with more detail. We'll be happy to support you. I know there are a lot of people in the webinar today that come from the speech industry. We look forward to reaching out to you and connecting with you and helping you with your speech recognition projects. With that, we can leave you some emails that will be on screen. Please contact us if you have you required any more information. Thank you, John. Thank you, Ken, and thank you to the whole Atexto team for this time. I hope everybody on the event took a little bit of information regarding what is happening in the speech industry and some cool applications that are there to support you. So thank you very much, and we hope to see you probably next month on our next presentation.